Hello and welcome students. Welcome to Engineers Arena. This is the discussion lecture of our test series. This is the test number 1.1 for surveying, strength of materials and environment. We are taking total of 16 tests. This is the first test, and as soon as we complete 5 tests, we will be completing our whole syllabus. So you can get the link of this test question paper on the below side of this comment box. Okay, now this is the first question which we have to do. This question is of surveying, and let us very quickly start the lecture and see what the question is. So first question is: an observer standing on the deck of a ship just sees a lighthouse. The top of the lighthouse is 49 meter above sea level and the height of the observer eye is 9 meter above the sea level. Find the distance of the observer from the lighthouse. So this is the question. So before starting this question, let us do something. Let us do some theoretical part of this. How can we understand? Suppose we are doing plane surveying. This is a staff which has reading 1, 2. Staff reading is from below and increasing upward. Suppose this is this we have surveyed and this we take as a reading. Suppose this reading is A. Okay. Now, when there is effect of curvature, suppose Earth is not a flat surface. So this was for plane surveying. This was basically for plane surveying. But when we do geodetic survey, that way we consider the surface of Earth as curve. When we do geodetic surveying, what happens is that this is the curved surface. This is the place from where you are taking reading. This is your staff. This is the horizontal line. This horizontal line. You are sighting this from here. You are sighting this from this position and seeing this staff at this position. They are taking this reading. So you have taken the reading. This is what? This is measured value. Okay, when we are considering curvature. Now, few terms comes in this. This is what is this? This is called level line. This is horizontal line. Okay, and this line I am drawing. This is basically mean sea level. This is mean sea level and this line is parallel to the level line. Okay, and this is, if we draw from here and it meets to the center of the earth. This is the center of the earth. Suppose this point is O. Okay, then what is this line called? This line is called plumb line. Okay, so first of all, what happens is that we actually wanted to take this position, this position. This is our measured value. When we measured, this will be our true value, which you wanted, and this is what? This is the measured value which you actually got. Okay. Now, what is correction? Suppose you are taking due to correction due to curvature, that is denoted by CC. What is CC? CC is true value minus measured value. Correction is true value minus measured value. Here true value is smaller, so we can say that it is negative. True value is smaller, since I already told that graduated staff is from its value increases from bottom end to above end. So the value of true value is going to be less than measured. True value is going to be less than the measured value. Therefore, this CC value is negative. Now from here we have got a result that value of CC is negative. Value of CC is negative. That is, this is basically CC. This is nothing but in figure. This is CC. That is coefficient due to correction due to curvature. Okay. Now, very quickly we can derive it also. It is very easy method where it is very easy to derive it. suppose this is the curvature of earth, this is the horizontal line, and this is the correction, CC. I'm taking one point as this is the horizontal line, this is horizontal line. Okay, I'm drawing this like this. Suppose this distance is D, this is what, this is R, and this is also R from here to here, and this is CC. So from Pythagoras theorem we can write R plus CC whole square is equal to R square plus D square. If we expand this, R square plus CC square plus 2R CC is equal to R square plus D square. R square cancels out. If we take CC on one side, CC, if we take CC as common, what will be it? This will be CC plus 2R is equal to D square. Now CC is equal to D square upon 2R plus CC. Okay. Now here you can see that CC value of, since radius R is in here is equal to the radius of earth, which is very large as compared to CC. So we can neglect CC over here, and we can say that CC is equal to D square upon 2R, which is negative. We already proved it. So value of CC is D square upon 2R. This is one of the result. If we put the radius of earth, as 6370 kilometer in this, then with the value of CC we will get is minus 0.0785 D square. So you should remember 0.0785 D square. Okay, which is negative. Here D will be in kilometer and CC is in meter. Okay, this you must remember in this equation. Okay, now if this was all for coefficient of curvature, correction due to curvature. Now curvature due to refraction. What happens is that suppose this is our earth. Okay, we are taking reading from here. Due to refraction, what happens is we want to sight this point. Our horizontal line. This will be our true value. But due to refraction, what happens? We measure this value. So this will be measured value. Now again, what is correction? True value minus measured value. Here you can see the true value is greater because we wanted to sight this one, and what we measured was this. Due to this ray basically bended due to change in density of the air. Okay, so we measured this value as MV, that is measured value. So this value is going to be positive because true value is greater than measured value. Over here you can see from figure. So and our survey expert says that this value CR is about 1/7 of, numerically 1/7 of D square upon 2R, which we previously calculated over here. CC 1/7 out, and this value comes out to, and this is positive, of course. This is positive. That is, from here CR is equal to plus 0.0112 D square. Okay. Now if we add both these corrections, CC and CR, this comes out to be minus of 0.0675 D square, where D is in kilometer and CC plus CR will be in meter. Okay. Now very quickly we come to the question now. Our question says, an observer standing on the deck of a ship just sees a lighthouse. The top of the lighthouse is 49 meters above the sea level. Suppose we are considering the curvature of the earth over here, because we are considering the curvature of the earth over here. So let me delete the above one. This is 9 meters. We draw horizontal line from here. We just sees, that is, this suppose this is 49 meter, this is going to be 49 meter. If it just sees that this is lighthouse, okay, and this is your observer's eye, here is observer, okay. It just sees the lighthouse, so we have drawn the figure like this, okay. Now suppose this line is D1 and suppose this is D2, okay. Find the distance of the observer from the lighthouse, that is we have to calculate what? D1 plus D2, okay. How we are going to calculate D1 plus D2? So we have already seen the formula that total correction, that is CC plus CR is equal to minus 0.0675 d square, okay. What was CC plus CR? This distance only, okay. Now what is this? 9 is equal to minus 0.0675 d2 square, okay. And second equation we can write 49 is equal to minus 0.0675 d1 square. Very simple. From here we can calculate d1 and d2, okay. From here we can calculate d1 and d2, so, neglecting this sign because the signs will be not important over here, although you must remember that it is always negative, total correction is always negative, that the sign is not important here, so I am neglecting these signs over here. So you have to, if you want to calculate, we can easily calculate d1 and d2 from here, okay. So what will the value of d2 if you do by calculator? You can use calculator. Also you can see that from here d2 can be also like this. To calculate d2 is equal to, that is if you take this as h, then d2 can be written as 3.855 h under root h, okay. So basically d2 will be equal to under root what we have written ct, that is it over here it is h, so d2 is equal to 3.855 under root ct, okay, ct1, that is this will be equal to 9, and for d1 similarly it will be equal to 3.855 under root 49. So from here you can calculate value of d1 and d2, okay. d1 comes out to be, what will be d1? Because I am writing over here d1 plus d2 is equal to 3.855 under root 9 plus 3.855 under root 49. This comes out to be 38.55 kilometer. This will be the answer. So it was a very simple question. Because we already just you have needed to understand that the question is from which part of surveying, okay. So moving to the next question. Next question is from photogrammetry, okay. A section, a line AB 300 meter long on a flat terrain measures 102.4 mm on a vertical photograph, okay. The radio tower also appears on the photograph, okay. The distance measured from the principal points to the image of the bottom and top of the radio towers are found to be 7 cm and 8 cm respectively. Average elevation of the terrain was 553 meter, okay. Determine the height of the tower. Take f is equal to 152.4 mm, okay. This is the question. So before starting this question you must understand what is relief displacement in vertical photographs, okay. Suppose I am observer at O and this is my plate, this is the negative plate, and I need to measure a tower over here of height h. Suppose this is what, this is mean sea level. Okay, I'm calling this point as k. Okay, this is suppose k dash, you can name anything. So at first what you're doing, you're sighting this, this is the top of the tower. Okay, then you're sighting which, I'm just changing the color. You're sighting this point. Okay, suppose this distance is r and this distance is r1. Okay, the height which is showing r, that is d, this, suppose this, now this is d, which is actually showing, which is actually called the relief displacement, and it is actually showing the height of the tower on your plate. This is the height of the tower on your plate. Okay, so d is equal to r minus r1. Okay, d is equal to r minus r1. Suppose this height, this total height is h, capital H, this is written by capital H, this is small h, therefore we can say that this is h minus h. Okay, and this is what distance, this distance is called focus. The distance from observer to the principal point is called focus. Okay, and d is equal to r minus r1. So if somehow we are able to calculate r and r1, then we will be able to calculate, we will subtracting those two and we will be able to calculate r minus r1. Okay, so let us see, suppose I just name the points. Suppose this point is A, this is B, this is C, this is D, this is E. Okay, I don't think I have to do anything more. Okay, suppose a triangle, we can see over here from triangle O K E is similar to triangle O C A. Okay, so from here we can write, OKE, this is E. Okay, we can write F upon H is equal to this distance. Suppose this distance is capital R, this will be also capital R. Okay, F upon H is equal to R1 upon R, capital R. Okay, we can write this, and again from triangle O K dash B is similar to triangle O K D. From here we can write that F upon H minus H is equal to R upon capital R. Okay, from here we can calculate R1 is equal to FR upon H, and from here we can write R is equal to FR upon H minus H. We can write this, and if we are subtracting these two, we can get the relief displacement D, that is D is equal to R minus R1. Okay, this will be equal to FR upon H minus H is minus FR upon H is equal to D. Okay, now we can just solve this. H minus H into H, this will be FR into capital H minus of FR H plus FR into small h is equal to D. So this will be cancelled, out. What will this equation reduce to? FR H upon H minus H upon capital H is equal to D. Now if we replace, you can also write from this, from here we can write R is equal to from here, not, if we can write from here also, but I am writing from here in this case, because I want the result with respect to R, not R1. Okay, so we can also write from here that R is equal to, capital R is equal to R into H minus H by F. Okay, and we are replacing this R from here to this. Okay, so F into R H minus H upon F into H divided by H minus H to H. Okay, what is this equations cancelled out, this FF cancel out, this D is equal to R into small h upon capital H. Okay, here we come to the equation D is equal to R into H by capital H. This is the required equation, this is the relief displacement, and this will be using in this question. So this was the basic theory of photogrammetry when we are using vertical photograph and we have to calculate relief displacement. Okay, now this question is based on this theory only, so let me delete this first and then we'll be starting this question fresh.